Good morning, students. Previous day we have discussed the derivation bending of cyclist in curves, and we have found the angle theta also. So that is one important question, and today we are going to a new topic and an important topic: moment of inertia. In this part, there are three 5-mark questions. Moment of inertia of a uniform rod, moment of inertia of a uniform ring, moment of inertia of a uniform disc. These three questions, then bending of cyclist in curves, then types of equilibrium. These are the important questions from this unit. And this is also one of the important. The three derivations given: moment of inertia of a uniform rod, uniform disc, uniform ring. If you know these three only, what are in the exam you will get one question. So first thing, what is in the moment of inertia? You know that while we studying the previous topic, there is a formula we derived I is equal to mr square, and I told it is moment of inertia. What is this m? Mass. M means what? Mass. And what is this R? R means distance. So what distance? I'll show you. You see, assume that one circular object like this. A disc. Assume that a disc, okay? A disc. Here another disc. Two discs is there. And assume that in this disc you have kept some point masses like this. Okay? You have kept some point masses like this, and in this disc you have kept some point masses this position. Okay. Now assume that you are placing a stick inside this, and you are allowing to rotate. Which one will rotate fast and which one will rotate slow? Which one will rotate faster? Yeah. In on which the particle which is closer to the axis, that will rotate what are fast, and here the distance, this distance, this is r, this is r, this is r. Here the distance is more, it moves slowly. Here the distance is less, so it moves fast. So here the particle is resisting this motion. The particle at some distance resists the motion. That is what moment of inertia. The tendency of an object to resist the angular acceleration, resisting this motion. Here this particle is resisting. You see the particle at some distance which resists its angular acceleration. That is what we are saying moment of inertia. Another good example you can tell is, listen here, this is a stick. In this stick, assume that you are holding like this, and you are trying to rotate like this. Now what? There is nothing to resist. It gives some motion. Take two stone or some two object and tie this position and rotate. So what will happen to this rotation? That rotation will be faster. At the same time, the same object you remove and tie both ends. Then rotate. Which one you will feel more easy? Suppose this object, two objects I am tying here with a rubber band. Two stone I am tying here with a rubber band and rotating, and another difference is tying here and rotating. So this distance is more, this distance is less. So when this distance is more, it is resisting the angular acceleration. This motion it is resisting. That is what moment of inertia we are saying. Now you see, to find out the moment of inertia, we are using the formula I is equal to mr square. Mr square. And for the bulk object and all, we are using I is equal to sigma m by ri square. For point mass, we are using I is equal to m by ri. This is for point mass and this is for bulk object, and for infinitesimal object, for very small object, we are using d is equal to dm r square. This is what dm means small mass. Here m means mass and r means what? Everywhere distance. This is what moment of inertia formula. Okay. So for bulk object, sigma m by ri square. For point mass, m by ri square. For infinitesimal object, very small object, to find out the moment of inertia, we are using dmr square. Then you have to integrate this. Okay. So I is equal to integration di will get integration di. So dm r square. That is one moment of inertia you can find out. Assume now we can go through the first question. Moment of inertia of a uniform rod. Okay, of inertia of uniform rod. You can see the textbook diagram. One diagram is one uniform rod like this, which is passing through the axis, and this distance is total distance is what? L. This total distance is L. Total distance is L, and this distance is half of this L, so L by 2. L by 2. This side -2, because when we are taking the coordinate system, this is minus x-axis, this is in positive x-axis. So minus L by 2 plus L by 2. Okay, and this is the origin. Here we are choosing a small object, small part. It says dm at a distance x. At a distance x. So this one distance is dx. Okay. The small mass distance is dx, and we are choosing an infinitesimal mass from this big rod and finding the moment of inertia first. Then we are integrating to find out the moment of inertia of this whole rod. Understand now? So first, what do you have to do? So we have to take a rod of length L, and we have to choose a coordinate system, and the line which is passing through its center of mass. So you can consider this uniform rod in x-axis, and from this you have to find out, we have to find out the moment of inertia of this uniform rod. So to find out this moment of inertia of a uniform rod, we are dividing into small parts. For that, you see, we are taking a small part dm, and it is at a distance x from water center, and this mass distance we are choosing a small portion, that one distance is water dx. Now you know moment of inertia formula, water d I is equal to dm r square. This dA means what? For infinitesimal object we are using what? Dm r square. and r means distance. This is our basic formula. Now what you have to do means we have to find the moment of inertia by integrating this. So I means what? Integration of dA. So I is equal to integration of dm r square. Now we have to find out this dm and this r square. What is the distance here? Distance is x. So I is equal to dm x square. Okay. Now we have to find out the dm. dm means a small mass which is taken from that water uniform rod. We can tell mass per unit length. A small mass which is taken from a rod. So that part we can tell mass per unit length. What a mass per unit length. For 1 unit of mass we are taking. That is what lambda we can keep m by l. M by l. And for that mass distance is what? L m by l into dx distance. Okay, that is what lambda. That is what lambda. And you see this is what the mass per unit length. We are choosing a small mass from this uniform rod dm, and this dm mass is what? Dm mass is a small mass per unit length we have chosen. That is what we are taking lambda. Lambda means mass per unit length m by l, and that what distance is dx. Now what you have to do means you have to substitute this. This dm formula is dm means what? Mass per unit length into dx. Mass per unit length into dx. So we can find out this dm value. dm is equal to what will come? M by L dx. That is what the mass per unit length for certain distance. From this rod we are choosing a small mass dm, and this mass distance is dx. That is what dm is equal to m by l into dx. Understand now? So listen here. First you have to write the basic formula. dA is equal to dm r square. Now what is, if you are integrating this equation, we will get the moment of inertia. For that dA means what? dA we have to integrate, okay? Then dm means what? dm we have to find out mass per unit length for certain distance, that we have to find out. So mass per unit length means m by l, and for certain distance is dx. Now you have to put this equation here. This you can keep it as equation 1, this 2. Substitute 2 in 1. So what we will get? I equal to integration of dm. dm means what? M by L into dx into what? X square. Now you have to remember we are finding the moment of inertia of this whole rod. The whole rod means its length is L. Its length is L. The total length is L. So we have to give some limit from which length to which length we have to find out. From minus L by 2 to plus L by 2. So minus L by 2 to plus L by 2, we have to find the moment of inertia. So I is equal to mass is constant, L is constant, take it outside. So M by L x square dx. That is what remaining, minus L by 2 plus L by 2. Upper limit, lower limit. Now integrate this, we know this format. X square dx means what? The formula x power n dx is x power n plus 1 divided by n plus 1. This is the formula. So x square means x cube by 3. So I is equal to m by L minus L by 2 plus L by 2. What are? We have to integrate. So x power 2 plus 1 divided by 2 plus 1 upper limit, lower limit minus L by 2, upper limit L by 2. So this is what integration. So I is equal to m by L x cube by 3 minus L by 2 plus L by 2. Now apply the upper limit and lower limit. So I equal to m by L, instead of x cube L by 2. So L by 2 the whole cube by 3 minus then lower limit minus L by 2 the whole cube by 3. Now next step I equal to m by n L by 2 cube. So what will come? L cube by 2 cube. 2 cube is what? L cube by 2 cube by 3. Here also. Then what? Minus into minus plus the same L cube by 2 cube by 3. So what will come? I equal to m by L cube divided by 2 cube is 8. So 8 into 3 plus L cube by 8 into 3. So I equal to m by L cube by 24 plus L cube by 24. Now you see the denominator part is same. So I equal to m by L cube plus L cube. 1 L cube plus 1 L cube is 2 L cube by 24. Cancel is 2 and 24. So you will get 12. I equal to m by L into L cube by 12. L cancel, so square will come. So I is equal to m L square by 12. You can write this. I is equal to what now? 1 by 12 m L square. This is what moment of inertia of a uniform rod. You can see this in page number 235. So again remember here moment of inertia of a uniform rod we are finding. Like this one rod, this rod is kept based on its center and a coordinate system. Center, what the coordinate system we kept through its center. That means this rod is kept on x-axis and this one length is L. Now we want to find out the moment of inertia of this uniform rod. For that I am choosing a small portion from here, dm I am keeping, dm. And this one distance is dx. That is what we are saying, mass per unit length for distance. And this dm is kept from origin at a distance x. So this r is equal to what? R is equal to x square. Now we are finding the dm. We have to find dm means infinitesimal mass, very small mass we are choosing, and mass per unit length. You see, this whole road we are taking first one mass, then another mass, then another mass, then another mass. Like this we are taking what? The small mass for this whole length from minus L by 2 to plus L by 2. So the whole length is L. So if we are dividing into half, this side is L by 2, another side is L by 2, but this is in the negative x-axis, so minus L by 2. And the dm value is what? Lambda dx. Lambda means m by L, mass per unit length. That is what? Now substituting this in equation 1. So I is equal to m by L dx into x square. Now we have to integrate with the limit. Limit we are giving for this whole length, minus L by 2 to plus L by 2. So m is constant, L is constant, take it outside, and remaining x square dx. Integrate this. Integration formula, x power n dx is equal to x power n plus 1 divided by n plus 1. Now integrate this x square dx. So x power 2 plus 1 divided by 2 plus 1, it is what? X cubed by 3. X cubed by 3. Now what do we have to apply? The upper limit, lower limit. Instead of x cube, L by 2 cube. So here minus L by 2 cube, and the next step you see L cube by 2 cube. L cube by 2 cube, and minus into minus become plus. 2 cube is 8. It is also a denominator. So 8 into 3. 8 into 3. Now what will happen? So 2 cube into 3 you can write down. So next step is what? 8 into 3 is 24. So 24 denominator is same. So take add L cube plus L cube. 1 L cube plus 1 L cube is 2 L cube. So 2 L cube by 24. And 2 and 24 cancel. So what will get? L and L cube. From L cube 1 L is cancelled. So remaining L square. So ml square by 12. You can write 1 by 12 ml square. So moment of inertia of a uniform rod you can find out by using this method. Still two more problem is there, not problem. Moment of inertia of a uniform ring and the moment of inertia of a uniform disc. These three questions if you are studying, you will get a 1 5-mark question. And this moment of inertia concept, when you remember this concept, you remember you have a sticker. Means what? We are tying two objects here and here. This one we feel easy. So why it is happening? It is due to the moment of inertia. Moment of inertia, it resists what? The angular acceleration of the object. So you can learn the formula I is equal to mr square. For point mass, mi ri square. For bulk object, sigma mi ri square. For infinitesimal object, dA is equal to dm r square. From that formula, you can derive the moment of inertia. You can find out the moment of inertia of a uniform rod. And based on this integration, there is example 5.14 in page number 235. And you can practice this problem in home, and you can practice this derivation. It is very important derivation. Thank you all. Bye bye. See you.